All right, let's go ahead and finish this section off. And we're going to be finding complex roots. So taking a complex number in polar form or rectangular even, and doing the square root of it, a cube root, fifth root, eighth root, any type of root. So if this is your complex number, and if w is not equal to 0, there are n distinct complex roots of w given by the formula z sub k is equal to, talk about n distinct complex roots, so that would be the nth root of r times cis of, and the angle is your initial theta, so theta sub 0 divided by n plus 360 degrees times k over n. So this gives you a formula, but it's going to generate your multiple roots. So that's going to be for k is equal to, you start with k equals 0, and then k equals 1, k equals 2, all the way up until you get to n minus 1. So let's see exactly how it works. So find all complex cube roots of -8 minus 8i. Leave your answers in polar form with arguments in degrees. So we need to figure out the r and also the theta. So -8 minus 8i, that's down in quadrant 3. And if you notice, it's an isosceles right triangle. So that makes your hypotenuse 8 root 2, and it's a 45, 45, 90 triangle. So your r is 8 root 2, and the theta or like your theta sub 0, that's your 225 degrees. So what we're going to do is we're going to figure out this thing right here. We're just going to we're going to fill it in, and then we're going to use it to generate all of our distinct roots. So z sub k is equal to, it has to tell you in the problem what kind of a root you're doing. So cube roots, so n is 3. So the cube root of your r, whatever it is, doesn't matter. Just take the r, and even if you're going, oh my gosh, there's a radical and a radical, that's okay. Welcome to the pre-calculus. So there's the cube root of 8 root 2 times CIS. Take your initial theta, so the 225, divided by the n, which is 3. And then plus 360 degrees k divided by the same n. And then simplify it down as much as you can. So the cube root of 8, that's just 2. And the cube root of a square root is a 6th root. And then let's simplify your fractions. So 225 divided by 3 is 75 degrees. 360 over 3, that's 120. So to get your distinct roots, your first one is when k is equal to 0. So whatever term is right here, it just gets knocked out, and you're left with everything else. So the 2, 6th root of 2, CIS of 75 degrees. So that's the first one. And then you can get the rest of them from there. So what this 120k does, it tells you how far apart each of these roots is going to be. So they're evenly spaced out every 120 degrees. So you just got to keep adding this number, whatever this is, the 120, to your 75 until you get all 3 cube roots, or until you get all 5 roots, or however many they're looking for. So the R stays exactly the same, but it's just going to start to rotate around. So 120 plus 75 is 195. And then if I add 120 degrees again, it would be 315. So those are your 3 complex cube roots of that complex number there. Okay, so that'll do it for the section. Let me know if you guys have any questions whatsoever. Yeah, and then we'll hit 9.4 next.